Now let us quickly revisit the slides that we had seen previously too for external interrupts. Now the reason we are doing it is a little bit of recap would be necessary because the external interrupt setup is a little bit more complicated than SysTick interrupt setup. So we know that the EXTI interrupt, EXTI, we will be using the EXTI0 interrupt, and we know that on the board that we have the user button connected to port A0. So now if the user button is connected to port A0 and we have to trigger an interrupt by pushing the user button, then the only way for us, without using an external circuitry, that is without using any other external circuit connected to our eval board, the only option that remains for us is to have this logically connected to the port A0 of the processor. So we will map EXTI0 to this. Coming to the next diagram, this is what we are going to do. We are going to use the sys CFG EXTI CR1 register, and we are going to map port A0 to EXTI0 because we have the, so this is what our logic is going to be. So we have the button here. So we have the user button here, which is connected to PA0. So we are going to configure the port A0 as input, and then we are going to logically connect or logically associate port A0 with EXTI0. So whenever we associate port 0 with EXTI0, EXTI0 is not anymore connected with any other port. That is, EXTI0 is only connected to port A0. It is not connected to port B0, port C0, D0, E0, and so on. It is now linked to port A0. This is what we are doing here. That's the first step that we take. After that, we need to take a few more steps to configure this interrupt. So the first one is the physical configuration, where we open up this port A. So we have to enable the entire port A. That is, we have to enable the clock for the port. Then we have to configure port A as an input port. Then link the port logically to the EXTI0, and then we have to do some EXTI0 interrupt configuration in the NVIC, for example, setting its priority, enabling the interrupt, so on and so forth, which we shall see in the code and the upcoming slides that you have already seen previously. So let us go to that diagram that we had seen, the architecture diagram, the block diagram that we had seen quite a bit in detail previously. So now if we have to set the external, so we are setting INTI0 as an external interrupt which will respond to the user button. And so which part of this block is going to be used? That could be a question. So we have to unmask the particular interrupt, and we are using it as an interrupt. We are not using it as an event. So if you are not using it as an event from the interrupt event controller perspective, we could still set the interrupt to pending in NVIC, which we have seen previously in the preemption demo. So that is not counted here. This is setting the interrupt as setting it as a software interrupt or event through the external interrupt event controller unit. So we will not do that. So we are not considering this part. So we will just unmask the interrupt, and then we'll have a pending request register. This is again different from NVIC, and then whenever an interrupt comes in through here, that is, so our port A0 interrupt will come in here. It will come through the OR gate, enable the AND gate. The interrupt mask will be this interrupt will be unmasked. It will go to the pending request register, and then it will go out through to the NVIC controller. So we are using only this part of the circuit. We are not going to use any of this. So this is out except for this part. So this is something that we are not using. So this part of the circuit is not used. We are not using this. Of course, this line is being used, but this part. So say this part is not used. This is out of bounds for us now, because we will not see this. What we'll use is, we will do a rising trigger selection, we'll do a falling trigger selection, all of that we will do. And then the external interrupt is going to come through here. It will go through here to the AND gate. So going to the next diagram, we'll just briefly see this, and we will see this in the IDE also. So we decided what interrupt to use, say EXTI0. We have no other choice because the board only presents us with port A0 connected to the user pin. Of course, we'll not need to choose the port, so it will be port A0. Now configure A as an input port, and port A has some restrictions because it's used for wake up and other things, but we'll not consider that here. So we are using port A0 purely as an input interrupt. We'll have to enable the interrupt line 0 in the EXTI IMR register. We have to set a rising edge trigger for the EXTI RTSR register. So EXTI IMR register enable interrupt line 0 would be unmasking the interrupt actually. Okay. So it is the interrupt mask register. So we'll have to enable the interrupt line 0 here, interrupt mask register that we saw. And then we have, for external interrupt, there's a separate external. So there's a, so this, we have this pending request, which is separate from the NVIC pending request. And this is how it is. So we can configure it for rising edge and falling edge. Level edge in this case is out of bounds. So we don't have a level edge setting. We only have rising edge and falling edge setting here. So we will set it for the rising edge in our case. We could set for the falling edge also, and we could set it for both. And then we will configure the NVIC for EXTI 0. Okay. So configuring NVIC ICR0 for EXTI 0, we'll have to know which interrupt number it is, and it is interrupt number 6, as we shall see in the reference manual. And yeah, we'll check from the vector table, and it is interrupt number 6. We shall see that, and then we'll set the interrupt priority, and setting the priority higher and lower than the SysTick and checking out interrupt preemption is something that we have already seen. And of course, two places to unmask here. Generally trend with all interrupt setting, one in the NVIC and one in the particular interrupt block itself, that is a particular interrupt unit, whichever we are using. So in this case, it is the external interrupt setup. So software trigger of interrupts we have seen before, so we are not going to deal with that here. So let's go to the reference manual now and check for the interrupt number first. Let's do that. So let's go to the reference manual. So you will have to keep moving between different manuals, of course. And this is the interrupt vector table that we have seen a few times before as well for the STM32F411 XC and XE. So, and EXTI0 here. So EXTI0 is interrupt number 6. So we have to use the position, interrupt position, not priority, and not the exception number. Exception number starts from here. So we talked about it. So let's not confuse ourselves. We'll have to take the interrupt number. So from wherever the interrupt number, actual interrupt start. And in that scenario, we see that EXTI0 is interrupt number 6. Now you have to check this every time you change your board. So it will not be interrupt number 6 in another board. It could be somewhere else. So the entire interrupt vector table that you have could look different in the case of a different hardware that you are using. So say you are using STM32F407, then this could be somewhere else. So you have to make sure where your interrupt where the interrupt is located, and depending on that you have to do your setting. And of course you have to also set up your interrupt vector table that way. Okay, so now where shall we go? Let us have a look at the code now, and then we will keep revisiting the the data sheet and the reference manual off and on if we need to. So just like SysTick handler, we will need to get into the startup file, and we'll have to see which is the INTI 0 handler. So here we made a mistake, I made a mistake. So let's see. So here it is written EXTI line 0, just in case it is not written. So how would you know that this is the right this is the right place where you have to put in the handler? So let's do this. So assume that there was nothing here. Okay, assume that there is nothing here. So let's go back to the, so we know that this is number 6. So this is 0 to 6, that is, it is the 7th one starting from the watchdog. Okay, and if you take from the beginning, the number is 1 2 3 4 5 6 7 8 9 10. So here you have some gaps. Okay, so you have to consider those many spaces here. Okay, and then you have to come down here and you have to exactly see what number you have. That is what is the entry number in the particular table that you have. So let's recount again. So 1 2 3 4 5 6 7 8 9 10 11 12 13, so 14 15 16 17 18 19 20 21 22. This is in the 23rd position. So let's see if that is in the 23rd position. So let's count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23. So you can see that our handler should be in the 23rd position. So and that tallies with what we have in our vector table. So this is how the vector table is mapped with the specification. So now, like we saw, we have to make this EXTI 0. So let's make it EXTI 0 handler. So now it is EXTI 0. Now if this is EXTI 0, we saw previously that the function definition also has to be, that is the definition is there. We have to change the function declaration also. If we don't change the function declaration, we are going to see an error like we saw previously. So let's do EXTI 0 handler here, and let's go here and let's change this. So now all our handler names are changed in the appropriate locations. Now we can get into the configuration details. So we have the EXTI 0 handler, but mind it, we also had seen it in the IO chapter. We have to configure the ports first. So the user button, so we had seen configuring the user button previously also. So we have to configure the port A user button, because that is the first step for our, so we have to wake up the port, right? So we have to enable the clock to the port, right? We saw that GPIO clock enable, and then in the AHB1 bus we have to enable the GPIO clock. So and GPIO clock in port A is in the 0th position. So if you remember this register AHB1 ENR, we have to set a 1 in the 0th position, then clear the button position and clear the pin mode. So what we do is we have the buttons clear variable set here, and we have to clear the mode for port A0. It is 1 1, so we are actually clearing the ports and making them 0, and of course the input mode for any port is set by default anyway, but we don't want to take any chances. That is why we cleared it here, and then again we are setting the port mode in the GPIO-A mode register. So what we are doing is we are creating a variable called button pins mode, and then we are just setting a 0 0 in position, bit position 0 and 1 in the GPIO-A mode register. Then we are going to set the pin to active low. Okay, so we may or may not set the pin to active low here, but let us do it anyway for to be on the safe side. So we are just in the POPDR register, we are just setting the pin to active low. That's what we are doing here. Once that happens, your input port is ready. Okay, so if your input port is ready, then you have to enable the output port, which we again saw in the input in the IO chapter or IO section. That is, we have enabled the output port, and we did something with the LEDs there. So I'm not going to go through this again. I'm just going to the user button because this is important as the input. This is the first point where you have to have this is from where you will press the button and your interrupt will come in physically. Okay. Then you have the actual setting up of the EXTI0 handler. Now the EXTI0 handler is going to be set this way. We need to go to the EXTI0. So here again we needed to make another change. So we do EXTI0 port A0. So this is the actual configuring the external interrupt for port A0. So we have configured the port now. So that is one step, because the port has to be woken up and configured physically. That is the physical electrical configuration. So configure the port electrically, setting it up as an input port, so on and so forth. But the EXTI line has not yet been associated with that port, and the EXTI interrupt itself has not been made ready to be to receive an interrupt. So this is the place where we do all that. So we disable the interrupt. So we do a CPS ITI because we don't want any interrupt to be coming in and disturbing this setup. So we just disable all interrupts, and then we set up a variable here as 0xf, which is 1111. Okay, and we are clearing the INTI0 field of the EXTI CR1. Okay, now this one, whatever you have here, EXTI CR0, okay, has to be set to all 0 to link it to the port A0. Okay, so we say if we are setting it all as 0 here, we don't need to do anything else because that is the setting. We don't need to clear the field and set it again as we did previously, where we cleared the field and even set a 0 again in the case of setting up the pin, the user button, like we cleared it. So we could have stopped here. We could have just cleared the field and we could have just stopped here, but we went ahead and put a 0. But in this case we are not doing it. We are just clearing the field and stopping it there. So let us do one thing. Let us go here and have a look at the register. So the register is this, where if you we have come across that register here, that is the EXTI0 syscfg EXTI-CR1. Okay, so the register name is syscfg EXTI-CR1, but the offset here is EXTI-CR0. Okay, because this is the zeroth element in the CMSIS header, but the name of the register is EXTI-CR1. Okay, so you have to be careful about that. If you try to look for the EXTI-CR0 register, you will not find it. So let's see, let's go to the data sheet and try to find out where the EXTI-CR1 register lies. So let's just go to home and do a EXTI-CR1. Oh, sorry. So we have this interrupt register 1. So if you see this one, we are actually setting this register EXTI-CR1, and all zeros is PA0 pin. So this is associating, selecting the EXTI-X external interrupt and mapping it to the PA0 pin. So that is what is happening here. Okay, this part. So if we had set it to 1, EXTI0 would have mapped to PB0, to PC0, PD0, and so on. As we saw, we are setting it to PA0. So this is the setting that we are doing. Going back, so now we have to enable this. So this is just the mapping of the interrupt. Now we have to enable the interrupt, right? So when we have to enable the interrupt, we have to set a 1 to the IMR register. So enable interrupt line 0. So we know that. Let's go to the data reference manual again, and let's check for that. So we are in the interrupt chapter, and let's type IMR here. So it's EXTI IMR. Let's go to the register. So this is the register, and MR0 is the interrupt line 1 is not masked. So if we set a 1 here in this register, in 1 here in the 0th position of the register of this particular register, we are going to unmask the EXTI0. So that is what we are doing here. In the 0th position, we are setting a 1 and we are unmasking the register or enabling the interrupt line 0. Okay. Now, since and all of this is commented, so that when you have a look at the code, it should not be difficult for you to understand what is going on here. Next step is, of course, setting up the rising trigger. So we are enabling the rising trigger now. So again, we have to go to the RTSR register, and again, in this case, in the rising trigger setup, check this out, is in the 6th position. Okay. So let's see that. No, sorry, this one. So configuring rising trigger in the RTSR, it is in the 0th position. So here it is in the 0th position. So 6th position comes later. That is in the NVIC. We know that it is it's the interrupt number 6. So we have to enable the NVIC. We have to enable the EXTI0 in NVIC also, right? So EXTI0 in the NVIC. So what we do is but in the NVIC, it is in the 6th position, because with respect to NVIC, this is interrupt number 6. So sorry again about that. This one is 0 and this one is 6, that is in the NVIC. So what we do is we set a 1 in the ISCR register. So let's see, let's go to the ISCR and check where we are. So let's do ISCR. Let's go home again. sometimes it doesn't. Just a moment, let us check ICR. Okay, so interrupt service enable register, let's NVIC. Oh, see, look, see, even I'm committing mistake here. We have to look into this sheet, the programmer's manual. It will not be in the reference manual, okay? Because this is general interrupts. We have to have a look at the, and so here we have to go in and look at the ICR, so interrupt set enable register. So in the ICR, as you can see, we have to go into interrupt number 6 here. This is the interrupt number in the case of with respect to NVIC for the EXTI0 interrupt. So we go there and we set the interrupt position to 6. Now we have to set the priority of the interrupt. So this, we played around with this priority before, so we have to set the priority in the NVIC. Now the priority setting is in the, again, is in the IP6. That is these are again. So let's have a look at the IP register and see how they are organized. Let's go to home. All right, NVIC. So let's go to IP. Okay, so IP goes like this, as we saw. So these are again 8-bit fields. So these are again 8-bit fields. So these are again byte addressable locations. Okay, so since they are byte addressable locations, we can actually go byte by byte. So this is the 6th or 7th byte, 0 1 2 3 4 5 6 or 7th byte. So this is the NVIC. So this is where it is going. So this is where you have to set the priority of this interrupt. So this is what we are doing here. And this one, if you see NVIC IP6, okay, so we have set it as a 8-bit unsigned value. Okay, check this out. And we have moved it to 4 left because we are using only top 4 bits for setting the priority. That is how the Cortex-M design goes. So the first 4 bits are set up as priority, and we are using all the fields for group priority. Okay, and then we are clearing that field first. That is the IP6. We are clearing that field first, and then we are setting the priority here. That is in this place we are setting the priority. That is 0 1 2 3 4 5, 0 1 2 3 4 5 6. So this is where we set the priority for that particular interrupt. So it goes like this up to 59, and as you know that there are, so and this is NVIC IPR0 register, which is a 32-bit register, but we are doing a byte access of these registers. So we spoke about byte access before also. So we are doing a byte access, and this is where we are actually doing all that. So this register, when we are, so here we are first clearing it, and then we are setting whatever priority we have here. So we are setting, so the priority is, currently we are setting a priority of 5. If it is 5 is 101, right? So 0101, we have to set it to 0101. So this is what we are doing. So in this particular register, we are setting 0101. That's all we are doing. First we are clearing it, and then we are setting 0101 in the NVIC IPR. Once that is done, you can enable the interrupt, and we are done with the configuration for EXTI0. We have not yet looked into the actual interrupt service routine. We have just configured the interrupt. So in the next part, we are going to see how the interrupt is configured, and we do something with the LED. So we will see that logic And as we know that writing the interrupt service routine is quite easy. It is just like a function, so that will be pretty straightforward.